For as long as humans have looked up at the night sky, one question has quietly followed us through history. A question so simple, yet so profound, that it challenges the very limits of science, philosophy, and imagination. Why does anything exist at all? Think about it for a moment. Every star burning in the darkness, every galaxy drifting through the vast cosmic ocean, every atom in your body, every breath you take, all of it had a beginning. According to modern cosmology, the entire universe began about 13.8 billion years ago in an event we call the Big Bang. But here's where the mystery deepens. If the Big Bang was the beginning of everything, space, time, matter, and energy, then what existed before it? Or perhaps an even stranger question emerges. What if there was truly nothing? No space, no time, no matter, no energy, no laws of physics, just absolute nothingness. Yet somehow, from that nothing, the universe appeared. Galaxies formed, stars ignited, planets were born, and eventually life emerged, beings capable of asking the very question of their own origin. How can something come from nothing? This question puzzled philosophers for centuries. But in the last 100 years, scientists began searching for real answers using powerful telescopes, advanced mathematics, and groundbreaking theories from physicists like Albert Einstein and Stephen Hawking. Their discoveries revealed something astonishing. The beginning of the universe may be far stranger than we ever imagined. Some theories suggest the universe could have emerged from tiny quantum fluctuations in empty space. Others propose that our universe might be just one bubble in a vast cosmic multiverse. And some physicists even argue that the concept of before the Big Bang might not make sense at all, because time itself may have started at that moment. In other words, the question of what came before the universe might be like asking what lies north of the North Pole. But the deeper scientists look, the more mysterious the beginning becomes. Because when we trace the universe back to its earliest moment, the laws of physics begin to break down. Space and time collapse into something called a singularity, a point where our current understanding of reality simply stops working. So the ultimate mystery remains. Did the universe truly come from nothing? Was there something before the Big Bang? Or is the universe part of a much larger cosmic story we are only beginning to understand? In this documentary, we're going to explore one of the greatest questions ever asked. We'll travel back to the very first moments of existence, examine the groundbreaking theories of modern cosmology, and uncover what scientists believe may have happened before the universe began. Because the answer to this question doesn't just explain the origin of the cosmos. It may explain why anything exists at all. The universe behaves in a similar way. Space itself is expanding. And if the universe is expanding today, then in the past it must have been smaller. Much smaller. If we rewind this cosmic expansion far enough, everything, every galaxy, every star, every particle, converges into a single incredibly hot and dense state. That moment is what we call the Big Bang. But despite its dramatic name, the Big Bang was not an explosion in space. It was the expansion of space itself. And it marks the moment our universe began. Today, the Big Bang theory is supported by multiple lines of evidence. The first, as we've seen, is the expansion of the universe discovered by Edwin Hubble. But the most powerful confirmation came in 1964. Two radio astronomers, Arno Penzias and Robert Wilson, were working with a large antenna in New Jersey. They kept detecting a strange background noise, a faint microwave signal coming from every direction in the sky. At first, they thought something was wrong with their equipment. They cleaned the antenna. They checked for interference. They even removed pigeons nesting inside it. But the signal never disappeared. Eventually, scientists realized what they had discovered. It was the afterglow of the Big Bang. Known as the cosmic microwave background, this faint radiation is the leftover heat from the moment the universe became transparent about 380,000 years after its birth. In other words, it is a snapshot of the universe when it was still incredibly young. Another piece of evidence comes from the abundance of light elements like hydrogen and helium throughout the cosmos. These elements were forged during the first few minutes after the Big Bang in a process known as Big Bang nucleosynthesis. Together, these discoveries strongly support the idea that our universe began in a hot, dense state nearly 13.8 billion years ago. But this still leaves a profound mystery. If the Big Bang created the universe, what created the Big Bang? Did time begin at the Big Bang? To answer that question, we first need to rethink something fundamental: time itself. In everyday life, we think of time as something that always flows forward. Seconds becoming minutes, minutes becoming years. Feels eternal. But according to modern physics, time may not exist independently of the universe. The revolutionary work of Albert Einstein showed that space and time are deeply connected. Together they form a single fabric known as spacetime. And this fabric can stretch, bend, and even begin. When scientists trace the expansion of the universe backward using Einstein's equations, they arrive at a moment where the density and temperature become infinitely large. This point is called a singularity. At this singularity, the laws of physics as we know them break down. But something even stranger happens. Time itself appears to begin at this moment. According to physicist Stephen Hawking, asking what happened before the Big Bang may not make sense at all. He famously compared it to asking, what lies north of the North Pole? There is no direction north of the North Pole. It is simply the boundary of that coordinate system. Similarly, the Big Bang might represent the boundary of time itself. If that's true, then there was no before. The universe didn't emerge from something earlier. Instead, time itself began with the universe. But not all scientists agree with this idea. Some believe there may indeed have been something before the Big Bang. And this leads us to one of the strangest concepts in physics. Can something come from nothing? At first glance, the idea that something could come from nothing sounds impossible. But in the strange world of quantum physics, reality behaves very differently from our everyday experience. In quantum theory, empty space is not truly empty. Even a perfect vacuum is filled with tiny fluctuations of energy. Particles can spontaneously appear and disappear in incredibly short periods of time. These temporary particles are known as virtual particles, and their existence has been experimentally confirmed. This phenomenon arises from a principle known as quantum fluctuations, one of the key ideas in modern physics. These fluctuations mean that what we think of as nothing is actually a restless sea of microscopic activity. Some physicists believe that our entire universe could have emerged from such a fluctuation. In other words, the Big Bang might have been a natural quantum event. A tiny fluctuation in a primordial quantum vacuum could have expanded rapidly, creating space, time, matter, and energy. One of the scientists who developed this idea further is cosmologist Alan Guth. His theory of cosmic inflation suggests that a fraction of a second after the Big Bang, the universe underwent an incredibly rapid expansion. During this period, space itself expanded faster than the speed of light, stretching tiny quantum fluctuations into the seeds of galaxies. Without these fluctuations, the universe might have remained perfectly smooth, with no stars, no galaxies, and no life. Ironically, the imperfections of quantum physics may be the reason we exist. But the story might be even bigger, much bigger. Some cosmologists believe our universe may not be the only one. Instead, it might be part of a vast cosmic structure known as the multiverse. In this picture, inflation never completely stops. Instead, different regions of space stop inflating at different times, forming separate bubble universes. Each bubble becomes its own universe with its own laws of physics, particles, and cosmic history. Our universe would simply be one bubble among potentially countless others. Some universes might collapse quickly. Others might expand forever. Some might contain completely different types of matter. And in many of them, life might never arise. But in a few rare universes like ours, the conditions might be just right for stars, planets, and intelligent observers to exist. This idea helps explain one of the greatest mysteries in physics. Why the constants of nature appear to be perfectly tuned for life. Perhaps they are not special at all. Perhaps there are simply many universes, each with different properties, and we happen to live in one where life is possible. Another fascinating idea suggests that the universe may never have truly begun. Instead, it could be part of an endless cycle of cosmic rebirth. In this scenario, the universe expands for billions of years before eventually collapsing under its own gravity in an event called the Big Crunch. When everything compresses into an extremely dense state, another Big Bang occurs, beginning a new cycle. Expansion, collapse, rebirth, over and over again. If this model is correct, our universe might be just one chapter in an infinite cosmic story. The limits of knowledge. Despite all these theories, the truth is that we still don't know exactly what happened at the beginning of the universe. The reason is simple. Our current theories break down under the extreme conditions of the Big Bang. Two of the most successful theories in physics describe the universe incredibly well. A general relativity explains gravity and the structure of spacetime. A quantum mechanics explains the behavior of particles at the smallest scales. But these two theories do not work together perfectly. At the moment of the Big Bang, where both gravity and quantum effects are incredibly strong, we need a new theory that unites them. Physicists call this missing framework quantum gravity. Until we discover it, the true origin of the universe may remain hidden. Today, scientists continue searching for answers. Projects like the James Webb Space Telescope are helping us look deeper into the early universe than ever before. Each discovery brings us closer to understanding our cosmic origins. But it also reveals something humbling. The universe is far more mysterious than we once imagined. And perhaps the greatest mystery of all is this: why does anything exist at all? And maybe the biggest mystery of all is that the universe became conscious enough to question its own beginning. From the birth of space and time, to the strange world of quantum physics, to the possibility of countless universes beyond our own, the story of the cosmos is far from finished. In fact, we may only be at the very beginning of understanding it. So the next time you look up at the night sky, remember this: every star you see, every galaxy hidden in the darkness, and every atom inside you may have emerged from one of the greatest mysteries in existence. The question is no longer just how the universe began. The real question might be what we will discover next. If you enjoyed exploring the origins of the universe with us, make sure to like the video,